Before the universe, there was nothing, only pitch black. But soon, in theory, the Big Bang happened. In a couple million years, stars began to form, and eventually our own planet. But according to the Big Bang theory, our universe is still growing. Now, how can we prove this? The answer is the redshift. To begin with, the redshift deals with something known as the Doppler effect. The Doppler effect is the change in the frequency of a wave for an observer moving relative to its source. So basically, in other words, it's the change in the frequency of a wave between a moving object and a stationary object. So let's talk about the waves. If there is a long distance between two objects, then it results in long wavelengths which have a low frequency. If the distance is short, then it produces shorter wavelengths that have a higher frequency. So think of it like Wi-Fi. If you're far away from your router or modem, then your Wi-Fi signal is probably quite bad. There are long wavelengths that produce low frequencies. But as you move closer to your router, your signal improves because of the higher frequency and shorter wavelengths. Now, the Doppler effect can be applied anywhere. Light, sound, you name it. But the redshift deals with it by color. So, as an object in space, a galaxy for example, moves farther away from us, the waves become long and have a low frequency. To the naked eye, the moving object emits a reddish tint. This is known as the redshift. But what happens if the object is coming closer to us? Well, the wavelengths become shorter and start to form higher frequencies. As the object comes closer, it produces a bluish tint, and this is known as the blue shift. So yeah, that's pretty much the redshift. Astronomers use this basically to support the Big Bang theory and prove that our universe is constantly and rapidly growing. Hey guys, this is Litfor. Hope you enjoyed the video. Be sure to subscribe, like, and share. Thanks for watching.